Unidentified drippings, weirdly warm drafts, wafting scents of garbage and rot? Yup, we're in a subway station. This sketch is about resting membrane potential, so step on over and we'll get started. Oh, yeah, definitely step over that steamy puddle. Resting membrane potential is like a cell's baseline. It's the difference in charge between the inside of a cell and the outside of a cell when the cell is not undergoing an action potential. A neuron's ability to send electrical signals relies on it being able to maintain and respond to changes in this charge. This oddly smudge-free barrier represents the neuron cell membrane. Everything inside the station, or on the same side as the track, represents inside a neuron. And everything outside the station barrier represents the extracellular space. For neurons, the resting membrane potential is around -70 millivolts. That explains why this train arrival sign has extra illumination on its -70, M, and V. Not another train for 70 minutes, though? Just my luck. In other words, the inside of the cell is 70 millivolts more negative relative to the outside, which is why there are neon negative signs all over inside the station. Electric potentials are generated by ions accumulating inside the cell and in the extracellular space. For resting membrane potential, the key ions are sodium and potassium. Peanuts are our recurring symbol for sodium, and bananas symbolize potassium. This peanut stand outside the barrier symbolizes that at rest, sodium is more concentrated outside the cell than inside. For potassium, it's the reverse. The banana stand is inside the barrier because at rest, potassium ions are more concentrated inside the cell than outside. Now, I don't know if those are special bananas or what, but that guy is way too excited to be here. The different concentrations of these ions on either side of the membrane generate concentration gradients for each ion, which drive the flow of sodium and potassium ions through leaky channels in the membrane. This transport is passive, so ions always diffuse from areas of higher concentration to areas of lower concentration. Kind of like the stuff leaking through these openings. The banana sludge oozing out and peanut water trickling in through these holes in the barrier represent the flow of potassium ions out of the cell and sodium ions into the cell through leaky channels. Each ion brings a positive charge along with it when it diffuses across the membrane. This generates an electric gradient in the opposite direction of the ion's concentration gradient. No wonder my uncle's been unemployed for 103 years. Dang robots stealing our jobs. These two robots represent the electric gradients for potassium and sodium. The banana robot vacuums bananas back in because potassium's electric gradient drives potassium ions back into the cell. Similarly, the electric gradient generated by sodium ions drives sodium ions back out. Hence, the peanut robot sweeping peanuts back out under the gap. Wait, is he refilling that bag with floor peanuts? Mine did taste extra salty.